here we go. 1.4, the Addition Postulate. Maybe you recognize that soundtrack from Batman Dark Knight Rises. A little geometry. Look at those angles in the bat wings here. We got angles. Maybe some segments going on. Let's talk about the Addition Postulate. That's all we're going to do. First one we're going to do, remember, postulates are things that we just kind of, we have to assume they're true. So they have to be true. Oh my goodness, what is going on? Alright, got a marker. So, 3 points A, B, and C are collinear. So I know that 3-point collinear means on the same line. So I'm going to say, if I have A, B, and C, they're collinear, and B has to be between A and C, so I got B right here in the middle. Then what has to be true? Aha! Then we know what? We know the measure of AB plus the measure of BC has to equal what? AB plus BC, so this chunk plus this chunk has to equal the whole chunk. That is it. That's the addition postulate. Boom. There it is. Write it down. Have it. No, it's great. And it makes sense. If you want to throw an example in, this is what we're saying. We're saying if this is 7 and this is 4, what is the entire total? Let me change colors. What is the entire distance covered from here? It's 11. So it's kind of common sense. That's why we can't really prove it. It just has to say it's true. Excellent. Let's look at an example of this. Oh my gosh. Mr. Kelly's an example. So we're saying, it's just like this. What if you have Mr. Kelly and you add to it just like AB plus BC Bane? So we're talking Batman. What are you going to get when you get Mr. Kelly plus Bane? Obviously you add those together, you get Bane Kelly. Holy cow, that's creepy. Maybe not the best example. Let's see how you're going to see it in your book here. The segment addition postulate as this example. So of course I got Bat here. So if given BT is 36, so BA is this chunk, AT is 2x, the whole thing, so this bracket means everything is 36. So can we set up an equation to show this? Sure, we're going to say this chunk plus this chunk is the whole thing. So 8x minus 14 plus 2x equals 36. And now it's a matter of solving this equation. So we're going to practice solving a lot of equations this time. Let's just leave this. Well, let's go ahead and solve it all the way out here. So how do I solve this? Well, I like to draw a line right down the middle. Boom. And what do we have to do? We have to combine like terms. So simplify this left side. What is 8x plus 2x? These are like terms, so mush them together. 8x plus 2x is 10x minus that 14 equals 36. And then what we do, get x by itself, so we're going to add 14 to both sides. Add 14 to both sides. So those cancel out. We're looking at 10x equals, what is that, 50? Take x by itself, divide by 10. We're looking at x equals what? 50 divided by 10 is 5. So I solve for x. Now down here it wants me to go ahead and find BA and AT. So can I do that? Sure. BA, remember, is what? 8x minus 14? So all you have to do is plug your 5 in there. So we're really going to say 8 times 5 minus 14. So we're looking at, what is that, 40 minus 14? And I subtract those, I get 26. So BA is 26. So this piece is 26. Can you tell me this piece? If this is 26, the whole thing's 36, what does it have to be? It has to be 10. So it has to work, and that works. X is 2 times x, so sure, 2 times x is 10. If you really want to write it out formally, AT is 2x. We're going to say 2 times 5, and we get the 10. Awesome. So that's what we're going to do, solving a lot of equations. First example is Bat. What's the second one? Haha, of course it's Batman. Rock and roll. So now can we fill them in? I give you these things. Can you fill it in? Sure. MA, the distance from MA, I'm going to go ahead and change here, is 5x minus 3. The distance from A to N is 30. So we got 30 here. The whole thing is what? 8x plus 6. So, can we set up an equation to represent this? Sure. The small two segments equal the big one. So we're looking at 5x minus 3 plus 30, boom, plus this equals the whole thing, equals 8x plus 6. And now we're going to solve this. So I draw a nice line down the middle, and I'm going to simplify each side first. So try to simplify. This 5x comes down, but what is minus 3 plus 30? Plus 27. You're combining like terms first. Now we can put all our variables on the same side. So what do I got to do? I want to get all my x's. I'm going to move them to the right side because there's 8x. There's more x's on this side. So I'm going to subtract them. Doesn't matter which side you pick. This will just keep negatives away. So those are gone. I'm left with 27 equals 3x plus 6. Now we're down to a two-step equation. Now we get x by itself. So we're going to subtract 6x. So we're looking at 21 equals 3x. And then what are we going to do? We're going to divide by 3. So x equals 7. And in this case, that's all they wanted. They just said find x. So that's cool. They didn't want any measurements. You could find them if you really wanted to. No worries. Pretty cool. Excellent. Holy cow, look at that. That is the Batman equation. There's actually a Batman equation. If you want to make this graph, go ahead. You can, let's not copy that one down. If you want to play with it, though, sometime, good luck with that. Holy cow, somebody has some free time on that. So really, this is all about solving equations. The setting up is not too bad. It's just, can we solve them? So again, go back to 3.4 because now we're combining like terms and simplifying. So if you want, this is a quick review just to make sure you're good to go. Hopefully, by now, two-step equations are great for you. Remember, I like to draw that line and solve it. No problem. The difference is, though, in number 2, what's going on here? Before I can start solving, like my first step over here was -1 from both sides. 2x equals 8, divide by 2x equals 4. But over here, I want to combine like terms first. So I look, is there anything I can do to either side of the equal sign? On the left side, sure, I have 2x's minus 5x's. Remember, it takes that sign in front. That's the tricky part here. So 2x minus 5x is actually minus 3x. So take that sign in front. Then when you get to here, you can solve. Not a problem. Subtract your 1 just like you did earlier. Now you got negative 3x equals 8. Divide by negative 3. So you get really negative 8/3 for this one. Fantastic. How about on the bottom here? So that's not too bad. Remember, we were doing variables on both sides a lot this chapter already. So remember, I draw them and I say, okay, which side has more? This has plus 2x, this has minus 3x. This side's bigger, so I'm going to bring them all over here, so I'm going to add the 3x. So hopefully, if you're this far, you've been doing a lot of solving variables on both sides, so it's not too bad. These are nice. Divide by 5, x equals 2. You're okay with that. But look at this monster. We're going to get some crazy looking equations now because we're going to set up some weird looking things. Don't freak out. It's not a problem. Number 4, do the same. I draw the line. I think it's a huge help. You've got the left side, the right side. Does anything on the left side simplify? Sure, you've got 2x's and 3x's, so really you've got 5x's, so add those together. But you also got this plus 1 and this plus 4, so what do you have? You have plus 5. Anything on the right side simplify? Sure, you've got 19 and minus 5, so what does that give you? That gives you 14 plus 3x. Make sure that sign's a minus. Now it's just like the number 3 over there. Now you're good to go. I'm going to move them. I'll change the colors here. I'm going to move everything to the left side because 5x bigger than 3x. So subtract that from both sides. I've got 2x plus 5 equals 14. Now solve for x. So if you're good at solving equations, you're going to blow up this test. A lot of solving equations. If not, it's just going to take a little more practice, but it's good. Great skills to have. This looks like 9/2 or 4.5 for x. Fantastic. So quick review. So really only one more. We did the segment addition postulate. There's only one more addition postulate. It's the angle addition postulate. So it's the same thing as a segment. It just looks a little bit trickier because we're talking about angles. Let's check this out. If B is a point in the interior, so if you check out of this angle DOG. So let's draw angle DOG. I kind of already drew it. O we know has to be the vertex. It's in the middle, so it has to be O. I don't care if you put the D on top. I will, so it spells dog. I guess I could spell God if you did it the other way. Either way. So I've got this DOG. As long as O's in the middle, you're cool. In the interior, I shaded. See that light blue? That's the interior. Everything out here is the exterior of that angle. So the interior is this blue region. What has to be true? If there's a point B on this interior of this, so there's a point B. Let's just draw it right here. What has to be true? Well, if I do another ray through this, what has to be true about this? Well, it looks like to me if you take angle DOB plus angle what? BOG, what does that have to equal? It has to equal angle dog. Pretty cool, huh? So this angle up here, angle 1, plus angle 2 equals the whole angle. So I don't know if it cuts in half or not. It may or may not. It doesn't matter. It's just like the line segments. It's going to add up to the total. And technically speaking, we're talking about the measures of these angles. It's really the measure of DOB plus the measure of BOG equals the measure of DOG. Just like we were doing before. So these angles add up. So if we pretended like in my example here, if we said angle 1 is let's say, what's it look like? About 30 degrees. And if angle 2 looks like about 35 degrees, what would the total DOG be? You could add them together. You could say 35 plus 30 is 65 degrees. So we can add these two together. Awesome. So can we solve equations with that? Sure, let's do another one of these. Oh, we got another Batman example. With Sully, there's Sully. What if you add Sully to, who did I add him to? Oh, no way. Did I really seriously do that? I'm getting a little nervous. I don't know if Mr. Sully's going to appreciate this or not. We've got Sully plus the Catwoman. What do you get? Obviously, you get Cat Sully. Wow, that is creepy. That is really, really creepy. Let's get that out of here. Maybe not show him. He may not appreciate that. I should have done Timmy Cat. Timmy Cat. Mr. Kelly loves to be called Timmy Cat and loves cats. Dang, I missed that. I missed the boat on that one. All right, let's do some examples though. We've got these angles here. So I'm giving you all this information. On your packet, I think I left one or two of these blank. Go ahead and fill them in. MAT is 60. I write right on the picture. MAT, boom, 60 degrees. What is MAH? Is the total. So the whole thing is 140. TAH is 4x plus 20. So I just usually fill in the two angles. It wants me to find x, so I know that this angle plus this angle is the whole thing. So I can say 60 plus 4x plus 20 equals the total. What is the whole total? The whole distance from here to here is 140. So it equals 140. So if you can set it up, then it's just a matter of solving the equation. That's why we did that quick review. Draw your line in there. Combine like terms. That looks like 146, doesn't it? That's a bummer. Let's make that one. So it really looks like 140. All right. So now, combine like terms. 60 plus 20 is 80. So I've really got 4x plus 80 equals 140. And now let's solve it for x. What do I got to do? Subtract 80 from both sides. We're looking at 4x equals 60. Divide both sides by 4. X equals, what is that? Goes in there once, goes in there 5 times. 15. So x equals 15. Fantastic. The finale here. So I've got math, love math. So I don't know, these aren't bisectors. I never said they cut each other in half. So even you can't just assume that they do. So please don't just say, oh, I think it cuts in half. Unless it says it, calls it a bisector, it doesn't. So now I'm telling you the whole LOE, the whole thing is 84. LOV is what? 4x plus 1. VOE is 5x plus 2. So I write them right in there just so I'm not confused. Make sure you get the angles named right. They all equal 84. So can we write that equation? Sure, it's going to be 4x plus 1, the top angle, plus the bottom angle, 5x plus 2, equals, what's it equal? 84 degrees. Half the battle, setting it up. The other half is, can you solve it? So let's draw our line. I'm going to find x. Combine like terms. We've got 4x's and 5x's is 9x's. We've got plus 1 and plus 2 gives us plus 3. Nothing to simplify on the right. It's just 84. And now solve for x. So we're going to subtract 3 from both sides. Looks like we're going to get 9x equals 81. Divide both sides by 9 to get x by itself. X equals 9. Awesome. So we found that x is 9, but it wants more. It wants the measure of LOV. So what is the measure of LOV? LOV is really 4x plus 1. So it's 4x plus 1. So I know x is 9, so plug in 9. 4 times 9 plus 1. 4 times 9 is 36, plus that 1 on there is 37. So really the measure of love is 37 degrees. Awesome. If you want to find the other one, you could. It's got to equal 84, so you could say 37 plus what number is 84. So the practice got some really easy ones and then some really challenging ones. I try to do the challenging ones here just so you have an example of some of the more difficult ones. And that's it, man. That's the angle addition postulate. We got the segment addition postulate, and we got the angle addition postulate. Good luck. I just want to show you a quick old school versus new school Batman. Wow, what a difference. Good luck on the mastery check. Peace out.
The guy in charge and saying, this new guy's going to get it right.
Well, that's just because I have confidence that I'll find happiness.
Hey, anything's possible, right? I mean, I once found the Batcave. Look, you can't expect to hire 60 workers to dig a cave under your house and then keep it a secret. I mean, those men live in this town.
Yeah, but I told them it was part of a geological survey.
Batman. They built a Lazy Susan for your nuclear car. That's something they consider conversation-worthy.